Once we have 7706, then of course we should just delete. I think realistically, 7706 could get us potentially 2x gain, potentially a little bit more safely. Ethereum's technical trajectory is actually looking very bright for the next few years. People will be surprised by how quickly we can accelerate on actually implementing them. For 2025, the priority just has to be
Welcome to PEEPanEIP, the podcast where we explore Ethereum improvement proposal with their authors, diving deep into the purpose, impact, and why they matter for Ethereum's future. This is episode 142, brought to you by Ethereum Cat Herders. I'm your host, Pooja. Today, we are discussing EIP-7706, a proposal that introduces a separate gas type for calldata. Documented in May 2024, the proposal is currently in the stagnant status, meaning there hasn't been any update in the last 6 months. However, that doesn't mean the proposal isn't valuable. Sometimes great ideas need more time before they get momentum. So what exactly is EIP-7706 and why should we care? To help us unpack this, we are joined by none other than the author of the proposal himself, a visionary whose contribution have reshaped not only blockchain technology, but also the way people worldwide think about decentralization, open innovation, and financial sovereignty. It's an absolute honor to welcome someone whose ideas have driven some of Ethereum's most pivotal upgrades, Ethereum's co-founder and deep thinker, Vitalik Buterin. Vitalik, it's a privilege to have you here. Thank you for all you do, and thank you for joining us on PEEPanEIP.
Thank you so much for inviting me, Pooja.
Pleasure is all mine. So generally speaking, our format typically includes a brief introduction before we get into the proposal. But Vitalik need no introduction. To our listeners, he has graciously joined us on PEEPanEIP in the past to discuss gas cost, optional access list, and the partial removal of refunds, Altair upgrade, and the block gas limit. So he is contributing his invaluable insight to the Ethereum community. Vitalik, before we dive into EIP-7706, may I request you to share a few words about what you are currently working on in Ethereum and beyond protocol development?
So within Ethereum, and one of the things that I've been thinking quite a bit about recently is scaling strategy, right? That's a topic that's on a lot of people's minds. I think the big success that we've had in 2024 is, of course, layer twos have increased by a lot in the amount of activity that they're supporting, in their security and their maturity. Two of them have reached stage 1, and there's a third one that reached stage 1 recently. So there's a lot of positive momentum, but at the same time, there's also a need for Ethereum's technicals to continue to rapidly advance in order to make sure that we're able to actually accommodate a potentially much larger amount of demand that could come in the next few years. And both the L1 and L2s are going to be a big part of that. And so actually, this ties very well into EIP-7706 because multidimensional gas actually is in some ways a scaling strategy.
Thank you for sharing, Vitalik. Your contributions have shaped the lives of millions developers, builders, and everyday users who rely on Ethereum for everything from finance to governance and beyond. I can't wait to dive into this. So without further ado, let's peep in.
So I think first, it would be good to start with the underlying theory behind this concept of multidimensional gas pricing, right? So today, Ethereum has a single gas limit, right? And it recently increased from 30 million to 36 million. And this gas limit mixes together all kinds of resources. So computation, reading and writing to Ethereum, storage, data bandwidth, the cost of approving the logs. So all kinds of things end up going into gas. And the challenge with this is basically, yeah, what I have in this diagram over here, right? So the way to think about this is that for a lot of the resources that matter, there's a certain limit that the network can safely handle. And then if you go above that limit, then that creates danger for the network. But if you go below the limit, then you're not actually buying the network anything, right? So for example, if you have a 10 Mbps data connection, then or say 10 megabytes per second to make the math simpler, right? Then if you have to download 5 megabytes in 1 second, that's fine. If you have to download 1 megabyte in 1 second, that's like also fine. You save 4 megabytes, but you don't really gain much by saving those 5 megabytes. If you have to download 10 megabytes, then that's like fine. But if you have to go and download 15, then like suddenly you'll have to take an extra half a second to download that data. And this is, of course, before taking into account some peer-to-peer inefficiency. And so that already actually starts to contribute to instability in the network, right? And so there's a lot of these resources where they're
Merci
better
les gars, je reviens.
modeled as bonjour Nicolas, as limits. And so the thing that we're trying to avoid is like usage that goes above those limits, right? And the interesting thing about this is that a single dimensional gas mechanism actually does a pretty suboptimal job of reflecting those constraints, right? And so here in this chart, I have, if we imagine a system where there's two resources, data and computation, and there's a limit to how much data the network can safely handle, there's a limit to how much computation the network can safely handle. Then if you try to create a line limiting data plus computation, then you get either one of two problems or both, where one problem is excluding blocks that are safe, but that have a large but still okay amount of data and a large but still okay amount of computation. And the other problem is accepting blocks that are dangerous because they have either too much data or too much computation, but they're still within the gas limit because even though they have a lot of one, they have like basically none of the other, right? And so like mathematically, you can think of the actual safe region in a two-dimensional graph between data and computation as a square. And any kind of region that you can create with a single line representing one gas limit has to be a triangle. And a triangle is never going to perfectly overlap with a square. And so you end up either inviting some amount of danger, or you end up actually having a much lower resource limit than you could be having. And so wants to try to get around this is by moving from a one-dimensional limit to a multi-dimensional limit, right? Where we basically say, well, instead of having one type of gas, we actually have two types of gas. And then those two types of gas have fees that float separately. And you have two limits for each type of gas, and you have two targets for each type of gas. And so basically you're accounting for each type of resource independently of the other. So EIP-7706 is an EIP that I wrote that actually accomplishes two goals at the same time. So the first goal that it accomplishes is it adds a separate gas limit for call data. So it actually accomplishes the goal of giving us multidimensional gas. And the reason why I picked call data is because call data is a dimension that is relatively disconnected from everything else. So it's not part of the EVM, and at the same time, it's a dimension that's like actually very valuable, right? Like one of the big DOS issues that we worry about actually is blocks that are very big in terms of data. And so if you separate out the gas limit for call data and the gas limit for execution, then that's something that actually is relatively low cost and relatively high benefit, right? So that's the first thing. And then the second thing that this EIP is doing at the same time is it's harmonizing the different forms of gas, right? So today we have execution gas and we have blob gas, right? And execution gas and blob gas are actually handled by different mechanisms. They're handled by different header fields. There's different rules for updating them. There's actually different EIP-1559 formulas for them. So there's a lot of fairly redundant and separated logic between them. And what the EIP does is it basically creates this nice mathematical abstraction where you're basically treating gas as being a vector instead of a scalar. And so a gas is now a list of integers, one integer for each type. And then we basically take all of the gas-related functions. So get max fee, get priority fee, get the gas a little bit of a transaction, get how much gas a transaction is paying, getting the gas limits of a block, you doing the EIP-7559 updating, and we basically convert all of those functions into this vectorized form, right? Into this form that just operates over all of the gas limits at the same time. And so you have the exact same logic working in parallel for every type of gas. And so this actually means that even though we're adding a dimension of gas, we're actually reducing total complexity. And once this EIP is put into place, it becomes extremely easy to add more dimensions of gas in the future, right? And so in the blog post that I wrote a while back, I asked the question, well, after call data, what are some other dimensions of gas that make sense? And one that I talked about is storage reading and writing. And I talked about some of the challenges of doing this. So basically, the challenge is like this problem of like subcalls needing to provide multiple gas limits. And I think my updated view from this is that like within EOF, there's actually, you don't have gas observability, and we should potentially just get rid of gas observability from the whole EVM. So the only thing you should be able to do is just make a subcall that provides the entire gas. And the main use case for doing anything other than this is like wrapped transaction mechanisms, so stuff like account abstraction. And I think those things should be just become base features of the protocol. But like there is more complexity in going beyond call data, right? But the point is that that's complexity that can be approached a bit later. And once EIP-7706 is in place, it becomes technically very simple to just keep on adding more gas dimensions potentially that have more parameters, right? So in the future, you could add gas for state accesses. You could also add gas for state growth, potentially other dimensions in the future as well. So that's EIP-7706.
Perfect. Thank you so much, Vitalik, for sharing about this proposal. We have requested our participant to drop the questions in chat. I see there is a question already. The question mentioned here is, should we push for SSD transaction EIP 6493 or at least SSD payload EIP 6404 in Beacon block to keep ideas like multidimensional gas less convoluted to sort of bookkeep in the protocol?
I would say yes. I think we definitely eventually need to migrate fully to SSZ. So my personal preference is definitely to kind of delay this somewhat. And I think one of the reasons why is that for 2025, the priority just has to be EOF and PeerDAS and increasing the block count. And while like I think Fusaka should have a blob count increase with PeerDAS and EOF and nothing else. But then once the like resources become available to do this, and I think doing 7706 and SSZifying everything in one batch is a totally good idea, right? It just makes so many different things cleaner at the same time.
Maybe a small follow-up on this. Do you think in the present spec, would we need to either change or adjust SSD proposals or 7706 in order to be both of them compatible?
I don't think so. I think when I wrote 7706, I was like thinking about SSD compatibility in my head already. So I don't think there's anything particular to worry about there.
I see there is another question in the chat. Nico, if you would like to relay that.
Yeah, how the framework can separate the standardized fee components from the L2 logic so you can be...
Separate the standardized fee component from the L2 logic. So far, we haven't really talked about L2s, right? But in the context of L2s, one of the ways in which this is valuable is that L2s already have to charge for data gas, right? And for like L2s already get their data gas cost and their execution gas cost from different sources, right? Because an L2's execution gas cost, it depends on the L2's execution gas limit and like congestion mechanics in the L2 itself. But the data gas cost of an L2 should basically be just directly borrowed from the underlying L1, right? And so for like if you're an L2, then like you have to already somehow like manage those two values being derived separately from each other. And so one really nice side benefit of EIP 7706 is that it makes it much easier for L2s to manage that because they can just have multidimensional prices and they can just inherit the L1 blob gas price as being their call data price.
So we learned about this new term, multidimensional fees. Could you maybe explain a little bit more? Can multidimensional gas allow us to widely increase gas limit? This is a question in chat by Gajinder Singh. And I would like to add a little bit more here, how it aligns with Ethereum's broader gas model.
Yes, so the answer is yes. So multidimensional gas does make it safer to increase the Ethereum gas limit. And the reason why is because the gas limit today is bounded by considerations about safety of like the Ethereum blockchain consuming more of certain resources. But each of those safety considerations is actually tied to a particular specific resource, right? So for example, it becomes dangerous if blocks become more than like 1 or 2 megabytes. It becomes dangerous if blocks take more than a full salad or potentially even more than like some portion of a salad to process. It becomes dangerous if the state size grows too much, right? Each of those limits are limits that are separate, right? And the problem is that because we want to avoid DOS attacks, we have to set those limits based on the worst case instead of based on the average case, right? Because there's always the possibility that someone will try to break the network by just filling the entire chain with block transactions that consume only one of a particular resource to try to basically cause the Ethereum chain to like shut down and break in exactly one of those ways, right? And so if we have multidimensional gas, then that actually lets us have separately set limits for each resource, and then we can set limits for each resource to equal exactly what is the theoretical maximum of that particular resource that we can safely handle. And so that lets the limit in terms of the average case transaction throughput increase by quite a bit without actually reducing or making any of the worst case bounds worse, right? So for people who are watching, I have on this chart, right? So we have this square and we have the line, right? And then imagine average case usage as being like a diagonal line. So data and computation have about the same amount. Right, and then if you think of that diagonal line, then, well, not quite diagonal, right, but just basically it goes through the top left and the bottom right, or bottom left and top right corner, right? Then you see how you have the gas limit, and even if you set the gas limit that accepts a little bit of danger, it still forces the average case usage to be like about 1.5 times lower in this particular example than the safe amount of average case usage that you can have, right? But with multidimensional gas, you're basically setting the two limits separately, and so your average case usage can go all the way up into that corner.
Thank you. And I think there is another follow-up, which is a combination of both L2 topic and multidimensional. How can multidimensional gas tie with the execute proposal?
So the execute proposal is basically stateless EVM execution, right? And there's a version of it where it gets re-executed directly, and then there's a version that gets executed with snarks. And so the execute proposal, like it basically involves doing extra EVM computation and including call data, but without accessing the state and like just basically without doing IO, right? And so in a multi-dimensional gas world, like you could basically charge for execute just by charging for calls and call data and charging for execution without charging for IO. And so if you have a block that contains a bunch of execute calls, but then you have other transactions that use IO, then those other transactions are still free to use as much IO as they want because that resource is not like taken up by the rest of the block yet.
Very well. I have learned about another proposal. Basically, we were discussing it in the PEEPanEIP of EIP 7623 about 7706, and that gave me the idea of having a broader discussion on this. So 7623, which increases call data cost in the upcoming Pectra upgrade, how do you think these two proposals interact, and how should developers be thinking about the combined impact in future?
Yes. So I think these two, in terms of the like resource bounding goal, they actually try to accomplish a very similar goal, right? So what 7623 does is it leaves costs unchanged for like basically not more than 99.9% of use cases. And at the same time, it reduces the theoretical maximum call data size of a block from about 2.7 megabytes to, I think, basically a little bit over 1 megabyte. And so what that means is basically that you can increase the gas limit safely without having to worry about like extremely large blocks creating worst case situations. 7706 solves the same problem. In my opinion, 7706 is cleaner and it is better. And it allows you to get much closer to an optimal solution, right? Because if you think about even the consequences of 7623, right? The worst case size of a block is about a megabyte. The average case size of a block is, I think, still about 100 kilobytes, right? So we've only managed to decrease the worst case to average case ratio from being like about 30 to being about 10, right? With 7623, or sorry, with 7706, you'd be able to decrease that ratio all the way down to the EIP-1559 max to target ratio. So basically all the way down to like, you could do 2, you could do 3 or 4 or something like that, right? And so 7706 is better. The reason why we did not do it is because 7706 is considerably more complex to implement, and it also requires a lot of work on the part of transaction senders, application developers, and so on, whereas 7623 is like basically a 10-line change. So it's like pragmatic short-term fix versus like how do we really optimally deal with this problem with finality. So once we have 7706, then of course we should just delete 7623 because we would not need it anymore.
That makes a lot of sense. But as I understand, it seems like there could be more research pending on 7706 and more studies. So what are the key milestones and criteria that will determine whether 7706 is ready for mainnet upgrade?
So I personally see 2 roadblocks. So one of them is just like the usual technical implementation, right? And so, like this, every EIP takes work. This EIP, it takes some amount of work on the EVM side. It takes some amount of work on the wallet and like application side to properly support it. And obviously, if we decide to bundle it with SSZ, then like that even adds even more work, right? Now for 762, or the other type of challenge is on the research side, right? And on the research side, I think there's still people who are looking for assurance that this type of EIP is not going to overcomplicate the mempool and is not going to overcomplicate the mechanism for choosing which transactions to include in a block, right? So the argument here is that if you have one type of gas, then the optimal algorithm is always very simple, right? You just include transactions, and if you have enough transactions to fill the gas limit, you just take the ones that pay the highest fee. In a multi-dimensional world, it potentially becomes more challenging. Now, with EIP-1559 does make this quite a bit easier in most cases, right? And the reason why is because even today with one-dimensional EIP-1559, like something like less than 10% of blocks actually end up hitting the limit, right? For most blocks, the limit doesn't matter, and all that matters is basically whether or not you're paying the base fee. So in a multi-dimensional world, you should assume the same thing. And actually, potentially, what we could do is we could say, well, we're going to do this multi-dimensional thing, and then we're going to make each of the limits be 3 or 4 times the target instead of 2 times. And if you do that, then like maybe even only 1 or 2% of blocks would actually hit the limit, right? And so you like Actually, the inefficiencies are kind of relatively small. They only apply in a small portion of situations, and there's like decent approximation algorithms. But these are all things that are conjectures, and like having sort of more rigorous study of that, and even taking a very applied approach using existing Ethereum transactions is something that would help a lot as well.
A lot of sense. It's not only just the research work, but also the coordination among infrastructure and a protocol would be required in order to maintain everything. So that's good to know. I see there is a question by Gajinder Singh. Would you like to go ahead?
Yeah. Hi, Pooja. Hi, Vitalik. And thanks for, giving this detailed presentation and the amazing answers to the questions. And there is one more question that I have. And since seems like blob capacity gets filled pretty quickly, and since the blob demand is generally inelastic, would we still be okay having call data as DA backup once we have the call data gas limit?
Right, I see it. I think realistically, there is a good chance that implementing this EIP would basically kill the like call data as the backup concept. And the reason why I would say this is because like if you just set the parameters based on today's usage, you could imagine target blob like call data or like total block without the blob size being say 128K, and you set the limit to 256K, and then you increase the blobs. And so like with Pectra, we're already going to increase to a target of 768. With PeerDAS, we increase to a limit of like 2 megabytes. And so the amount of extra space that you get by putting things into call data is going to become tiny, right? Like today, what we have is we have a world where post Pectra, right? We'll have a world where blobs are 768 target, but then you also have this like stretch space where you can use the call data all the way up to a megabyte. And post this, like that stretch space will decrease, and then at the same time with PeerDAS, the number of blobs will go up, and so that whole use case is going to just become much less economically relevant.
I may have a follow-up here as we are talking about blob-based. I wonder, would implementing EIP 7706 require updates to blob-based fee instruction that was outlined with EIP 7516?
No, I mean, obviously it would have to be repointed to points to, the what now becomes the second gas dimension instead of like what was blob gas, but that's like a fairly trivial thing. It just points to a variable that does the same thing as what it did before.
So maybe we would need another smaller EIP in order to just point it to the new.
Right. I think realistically, probably just adjust this EIP to clarify that the blob base fee opcode would points to this variable.
Yeah, I'm not so sure because this has already moved to final and has been deployed. Maybe it will come from process point of view to altogether have a new proposal and mention the new specs changes in that, because that's going to be an important change to any proposal. Very well. I have another question with respect to efficiency. Would you say EIP 7706 is a long-term scaling solution, or is it just primarily an efficiency improvement that we are trying to bring it for existing use cases?
I think realistically, 7706 could get us potentially 2x gain, potentially a little bit more safely. So I see it as potentially a valuable improvement, but I definitely don't see it as a substitute for other forms of scaling.
That make a lot of sense here. Also, in the same direction, I'm just trying to understand, was it always the part of plan, or this proposal was conceived because of a growing Ethereum usage?
I think this idea was one that we've been floating around for quite a few years now. I actually forget when was the first time that it was brought up. I think definitely after we started bringing up EIP-1559, because I think without EIP-1559, the knapsack problem issues probably do end up overcomplicating like block building too much. Like definitely, after EIP-1559 was like a thing in discussions. Yeah, I don't remember when it actually first appeared. Like it could have been 1 or 2 years, it could have been longer.
Sure, yeah, but we recently found this proposal documented because 1559 was long ago and the proposal was originally documented. But I understand it takes time from ETH research to come up to EIP GitHub repository. We are talking about separating call data gas from execution gas, and that represents a major shift. What are the key trade-offs, and why do you believe this simplification ultimately benefits Ethereum?
So I think there is a balance here between a kind of effectiveness and complexity, right? Because theoretically, you could potentially go all the way, right? You could literally say, like, we're going to have a limit for literally every single individual opcode. And there's actually even an argument for why that might be a really interesting and good thing to do. And the argument is basically that if you discover that there's a bug in the implementation of one opcode that is a DOS attack, then if you have a mechanism where like that every single opcode only gets assigned like basically a 50th of the total usage, then like if you DOS attack one of them, then like even if you manage to slow it down by like 50x, then you're only like slowing down the entire execution by 2x, right? And so you get something that's like incredibly resilient and robust. The problem with taking that approach is, I think, like one is it becomes like much more confusing for developers. Two is all of the issues around like inefficiency and having more volatile fee markets will probably end up multiplying, and it'll become plausible that like one single application will just cause a few particular gas limits always get hit. Then three is just the overhead of having really big vectors. So if you have like literally 50 dimensions, then a transaction, for gas price, start price, base fee, and so on, like you would literally have to have like 600 gas or something like that. So I would say, yeah, those are probably the main reasons, right? And so to me, yeah, saying that we're going to have somewhere between 3 and 6 dimensions feels like a pragmatic compromise. And so I argue, like start with the 3 and basically the most natural one as a foot in the door. And then in the long term, I absolutely endorse exploring adding a couple of other dimensions as well.
That's quite an optimistic approach here. 3 to 6 dimensions are taking too many parameters into consideration. So with separate gas types, there is a question of a potential fee fragmentation. Do you see any risk in balancing execution gas, blob gas, call data gas, and how that can be managed?
Yes, it is a risk. Like it basically, it makes the optimization problem for a developer more uncertain because they might end up optimizing for one regime, but then you have like some long-term secular change in what other people do. And then as a result, you have like a long-term shift where maybe before execution was expensive and call data was cheap, and then now execution becomes cheap, call data becomes expensive, and then if you introduce more dimensions, then like maybe you have changes in relative prices between execution and IO, and then of course if you have like 50 dimensions, that problem becomes completely crazy. And so for a developer, the optimization problem definitely becomes more dynamic. And I think it is still doable, right? Like if I was a developer, the thing that I would do is I would just look at average base fees of all of the resources over the last year. And then like that's what I would use to figure out like what is the total objective function that I'm optimizing over, right? So I think, that's fine, but like that definitely is one of the like extra complexities that adding more dimensions introduces.
And I'm sure there would be related research in upcoming days. We would be in a
Mhm.
position to overcome this concern. And talking
Yes.
about concern, there is a common concern with increasing gas limits or reducing call data cost in Ethereum. Theoretically, maximum block size. How does EIP 7706 strikes a balance between efficiency and affordability there?
Okay, so today the average Ethereum block size, I mean, I can actually just quickly look it up. I think it's definitely going to be a good number for people to know. So if you go to Etherscan charts, then you basically just like scroll down, you go to average block size, and you scroll down a bit more, then you see recently it's been at like basically about 75 or 80 kilobytes, right? So like very small. So before the Pectra fork, the theoretical max size of a block, this is still assuming the 30 million gas limit. We don't even really have significant data for the new higher limit now, was 2.7 megabytes, right? So 2.7 megabytes divided by 75K, so actually about a 40x ratio of like worst case to average case. And then post 7623, I think if you look up 7623, then the token cost floor basically, right, so you still have the 0 byte mechanism. I still doing that thing, but it basically reduces everything by 2.5. And so realistically, like you get something like 1.1 megabytes, right? And so with EIP 7706, what we would do is we would probably just like set the target to be either somewhere close to current usage or potentially a little bit above current usage, right? So like I suggested 128K is like a decent plausible number, probably reflects what we would get to if the gas limit was increased to like 45, like 50 million or so. And then you would be able to set the limit to be either like 2x or 4x that, right? And so the worst case becomes lower, and what that means is that it becomes safer to stake with lower levels of bandwidth. And generally, we would see lower network instability from unexpectedly large block staking a long time to propagate. And that in terms of cost for users, like if we set the target to be above what the current usage is, then the cost experienced by users would actually decrease.
That sounds good. Thank you so much for sharing. I see there is another question. Gajinder Singh, please go ahead.
Yeah, with regard to the resources, since you mentioned size and bandwidth is one of the resource, and then the multidimensional gas limit is sort of placing different limits based upon different resources. But in the end, we have to sort of define these particular benchmarks with regard to a standard hardware. And as the standard hardware keeps on improving year on year because of the Moore's law and other laws, like there is a bandwidth law as well. So how do we basically keep pushing those limits as the improvements happen on the hardware space?
Yeah, so the nice thing is that if we have multidimensional gas limits, then we should be able to reverse engineer the correct limit for each resource directly from like what the hardware spec is and like how long it takes the hardware to like run a certain amount of EVM gas, or like how efficient the peer-to-peer network is, and what we know about those kinds of variables. And so we would be able to adjust the limits separately if the trajectories of improvements in bandwidth end up being separate. And so I think it actually opens the door for a more principled approach to doing that. And then for how the gas limit can be changed, I think this is something that this EIP does not yet change, right? So this EIP actually tries to keep the way that gas limits are decided like about the same. But I think what we could do is like I'm personally in favor of just making all three limits separately votable by stakers.
Thank you. Let's talk a little bit about economic and scalability impact. We briefly discussed about layer 2. So one of the Ethereum's greatest strength is the ability to adapt and scale over time. With more application relying on a roll-up and call data heavy transaction, how do you think EIP 7706 will affect transaction cost for both users and developers?
Yeah, so for users, I think transaction costs will decrease as a consequence of the scaling improvements that 7706 can enable. And another thing is that I think it's possible that for certain kinds of applications, fees would even be less volatile, because if you have one application that dominates one particular resource, then the other resources would not be affected. And then for developers, in terms of like actual transaction fees that you have to pay, it's like pretty similar. Although I know that people have been making, like things like gas derivative markets, so like basically ways to let people pre-purchase gas. And so those platforms would have to adapt themselves to handle the multidimensional gas world.
That is great. And I would also like to understand a little bit about security consideration with respect to implementation. So, Ethereum security and decentralization has always been the top priority. So, are there any security consideration or challenges that were carefully accounted while documenting this proposal, or maybe something which hasn't been accounted but still under consideration?
Yeah, so I think one of them is this issue of like optimal block select, like building mechanisms, right? Basically, if you're a builder and then one or multiple of the gas limits actually gets full, then like how do you prioritize when the individual things are multidimensional, right? And like there are algorithms that can get a pretty close to optimal algorithm, but like this is one of those things that needs to be explicitly thought through. And then the other thing is the mempool, right? Because with the mempool, there's currently some rules that have to do with allowing, for example, a transaction to overwrite another transaction if it's like in the mempool. If its gas limit is higher by a certain amount, there's rules about like how gas transactions get prioritized if there's too many transactions in the pool. And all of those rules would have to be adjusted for the multidimensional context.
Glad to know that we are already about of these concerns, and possibly it will be addressed in future when we are getting into more finalized version of the specs. With that, the one question that comes to everybody's mind, and I think it is also shared in the chat itself, when can we expect this proposal for Ethereum mainnet? Maybe you can answer in terms of number of upgrades from now.
Yeah, I think realistically, either 1 or 2 after Fusaka would be a good time to target.
That is good. And a follow-up question on this. How do you think teams should best coordinate and come to consensus to Ethereum developer product roadmap in terms of this EIP?
Yeah, and so I think like the first step here, obviously, is that we should be continue to do all of the research that I talked about. Then separately, at some point, core developers will have to start coming up with priorities for the fork after Fusaka. And so I think this will become one of the discussions. And I think as an input going into discussions, like we would want to know what are the actual priorities for 2026, right? Because for 2025, it's obvious on the execution side, it's EOF, and for the consensus side, it's blobs, and more blobs. And then 2026 will be inundated by blobs. And then on the execution layer side, if a priority ends up being like scaling, but through further gas limit increases, then we would want to look into this as a way of making the gas limit increases safer.
Yeah, and in the chat, it was mentioned in general as well. I think you probably touched a little bit on that, but if you would like to add anything on top of it. So we are just trying to understand here, like if you have any suggestion on the coordination part when we can both come up with a joint roadmap.
Right. I see. Yeah, I mean, I think like in general, my view on this is that I think step 1 is agreeing on underlying goals, right? And step 2 is then agreeing, like actually seeing like which EIPs do a good job of contributing to some underlying goals, right? So for example, if the underlying goal for 2026 ends up not being L1 scaling, which is plausible, right? So like, for example, if we end up taking a very sort of purely L2 focused approach, increasing the gas, then it's very plausible that L1 effort would go toward other things. But if we decide that scaling is a priority, then we're going to have to say, for example, how would Verkle trees affect scalability or alternatives to Verkle trees? How would 7706 affect scalability? How would just like gas repricings that are simple and more direct affect scalability? And so we would end up like judging and prioritizing based on the answer to that question.
Thank you for sharing. And before we move out of this topic, one final question on this. We in Ethereum have always been working on community collaboration. So how do you think developers, researchers, and ecosystem contributors may get involved with EIP 7706? Are there any areas where client team need additional insight or implementation support?
Yeah, I mean, I think if you're a researcher, then the natural research problem here is basically the one that I talked about, right? It's like a very specialized application of multidimensional knapsack problems, which is something that is like fairly well studied in computer science, though here there's obviously like a few unique mechanics, right? Like there's the EIP-on 559 mechanism, and then on top of that, there's just the empirical question of like how transactions actually like look and work in Ethereum. So like giving an answer to the question, like basically here is a specific proposed algorithm for either doing block building or for managing the mempool, and then say, yeah, come up with actual math like that shows that given a sample of transactions from the average Ethereum chain, like it actually gets you to like 90% of optimal or 99% of optimal. That's something that would be very valuable for this whole effort. Also, ETH research continues to be a good forum for talking about this. Yeah, I mean, I think it's a combination of those.
Well, thank you. I mean, you already mentioned that this is a robust proposal, but perhaps it's complex to implement. So any and all kind of support are welcome on this proposal. I see one other question, or I don't know if it is a question or a comment. Nico, if you would want to take it.
No, I was just saying that indirectly having a standardized multidimensional gas on L1 helps L2 to have a standardized way to do multidimensional gas. So in a way, we can say that it also helps L2. So
yeah, I agree. And one thing I would add is even if we say pre-agree to have 7706 in Glamsterdam, then potentially L2s could adopt it ahead of L1. Because ultimately, yeah, like L2 is getting value from this, doesn't technically depend on having L1 have it already on mainnet.
That's true. Very well. That brings us to the end of all the questions on EIP, but definitely not all for the day. We have something more interesting coming up. Before we get there, I wanted to share a couple of fun facts with you. So as per EIPsinsight.com, Vitalik Buterin has contributed to over 20 plus EIPs on Ethereum network upgrades so far, and so many more are there in line. So thank you so much for all the job you have done so far, and we look forward to have more. And also on a related note, I was looking into our past episodes. I mentioned in the beginning of this conversation that he has graciously taken out time to talk about so many proposals. Our last discussion on block gas limit was episode 42. And this is such a coincidence. 100 episodes later, we have you here on episode 142 to talk about EIP 7706. Thank you so much, Vitalik, for making out time to share about upcoming proposals.
Thank you too, Pooja.
Very well. That brings us to the rapid fire round. So we are gonna share a few questions with you. We'll try to get answer either in one word or one sentence in 1 minute. Are we ready?
Okay.
Ethereum in 2030.
Lots of scale, lots of applications using it, much better privacy, much better user experience, global platform for building the open decentralized world.
Most exciting EIP ever.
The merge.
The biggest misconception about Ethereum.
I think 10 years ago, the answer was that like a lot of people thought of Ethereum as being just a coin. I think today, I don't know. Like, I think today there's just like so many groups of people that have so many different opinions.
Opinions. That's correct. All right. What would be the one word to describe DAOs?
Interesting.
What's missing in Web3 today?
Public goods funding.
If Ethereum had a spirit animal, what would it be?
Okay, I'll say Phoenix.
The future of DeFi, exciting or chaotic?
Some of both. I think we'll see a portion of DeFi continue to be more safe, more reliable, and just more useful in more and more boring and mainstream ways. And then there's going to be a portion that just continues being totally crazy.
One word to describe the Ethereum community.
Special.
The most overhyped blockchain trend.
Ripple.
One word to describe the role of social layer in Ethereum.
Important.
The key to sustaining public good funding.
Better mechanisms.
Most underrated factor in blockchain adoption.
I think, okay, within the technical group, I think on-ramps and off-ramps.
The most important value Ethereum should never compromise on.
Openness, decentralization, censorship resistance.
If you could rename Ethereum, what would it be?
I would not rename Ethereum, but I would revive the EIP from way back then to rename gas to mana.
Okay, this was not the part of the original plan, but I have added it from my own end. The first word that comes to mind when you hear PEEPanEIP.
The.
Thank you, Vitalik.
Thank you, Pooja.
It was very interesting to hear your thoughts. I have always found them inspirational, so thank you for sharing them. Before we wrap up, I want to take this moment to acknowledge and say that not just technology, but you have affected the lives of people here. You have enabled the entire generation of builders to create, innovate, and redefine financial and governance system. This is not just about code, it's about empowerment. As we look ahead, do you have any final message to be shared from this platform for Ethereum community, developers, validators, researchers?
I think Ethereum's technical trajectory is actually looking very bright for the next few years. We know what the most important goal is. The most important goal is, to scale, and scale more while maintaining the special status of Ethereum as a decentralized platform and a decentralized community and ecosystem. And there's a lot of different strategies and approaches to that have all become much more mature in parallel. And I think people will be surprised by how quickly we can accelerate on actually implementing them.
We always appreciate, Vitalik, you taking out time and sharing all this information. It's invaluable, not just for helping community stay informed about what's ahead, but also for your dedication to knowledge sharing and open collaboration. I'm grateful that PEEPanEIP can play a smaller role in supporting Ethereum education, and having you here is a kind of testament to the fact that education matters and we truly are trying to support the Ethereum ecosystem. So thank you, Vitalik. It's been an absolute honor having you on PEEPanEIP.
Thank you so much for having me, Pooja.
To everyone listening, if you would like to learn more about EIP-7706, contribute to its development, be sure to check out the proposals discussion and related research work. Check out links in description and related proposal. That's all for today, but we'll be back soon with another intriguing proposal to explore. Until then, keep learning, keep building, and keep perfecting the Ethereum blockchain. This is Pooja Ranjan signing off.